Welcome back, everyone. In Unreal Engine, blueprints are a very important part of the game development. Think of blueprints as a collection of various different components with some logic behind it. So things like a player, an enemy, a collectible, a car you can drive around, all those things are blueprints, as each of them have their own collection of components and logic that we can define for it. So let's take a player, for example. With a player, they would have their player model, the 3D model for the player. They would also have a camera, they would have a collider, and they might have a weapon such as a sword. So those components put together is what we would call the player blueprint. So let's start off with actually showing you how you can create a blueprint. So here in the content browser, to make things nice and neat, I'm going to create a brand new folder. So I'm going to right click, go new folder, and I'm going to call this one our blueprints. So inside of this folder, what we want to do is right click and we want to select create basic asset blueprint class. And what we need to do first of all is pick a parent class. Here we have a list of common classes, and whenever we create a blueprint, we got to sort of inherit from this class. So depending on what we want to create, we'll pick a different parent class. First of all, we have actors. Actors are the most basic aspect of anything in your game. Everything in the game is an actor pretty much. An actor is just a object that has a position, rotation, scale, and very basic properties. Next up, we have a pawn, and a pawn is basically a object that can receive inputs from a controller, and a controller doesn't necessarily mean just a player. The player can, of course, be in control of this object, but this could also be in control of an enemy AI as well. So if we're creating some basic sort of player, we'll be using a pawn, or if we want to have an enemy that can run around and receive inputs that way, we can also use a pawn. Next up, we have a character, and a character is what you would use if you're creating a first-person shooter or something like that. This comes with a few built-in components. It comes with a mesh, a collider, and a few other things, so that creating a first-person shooter or a third-person game is very easy by using this character blueprint. And it also comes with some logic as well to make it easy to move around, to jump, just some overall character controller physics, which is really easy if you're using this as your parent class. Player controller is basically the same as character for the instances that you'll be using it for. Next up, we have a game mode base. Now, every single level in Unreal needs to have a game mode assigned to the world. And a game mode basically defines things such as what is the player? Because when you press play in the game, how does the game know which blueprint you want to be the player? The way it does that is by you assign a game mode to the level, and in that game mode, you basically tell it what the default thing for the player is, what the default UI is. So when the level starts, it goes, all right, this is the player, this is the UI, and so on and so forth with any of the other things that you want to set as a default. Now, for our instance here, we are going to be creating a blueprint of a little controller player that we could probably move around a bit. So what I'm going to do is I'm going to select the pawn parent class here. I'll select that, and it's going to ask us for a name. I'm just going to call this our player. Press enter, and here we have a new blueprint. Now, what we can do with the blueprint is double click it to open up, and this will open up a brand new editor. This will open up the blueprint editor, and what we can do is click the tab and drag that so it docks with our window here, just like a web browser. And inside of here, it looks different from the level editor, but it does have the same sort of panel setup, how we have different panels. We've got a viewport in the middle. So let's go over real quick what each of these things are. First of all, up in the top left, we have our components panel. And in here is where we have a list of all our different components. We have our 3D models, we have our colliders, our cameras, everything that you want the player to have will be listed here. Okay, then we have the My Blueprint panel, and this is basically the list of all of our variables, our functions, our event graphs. We'll get more into event graphs a bit later on, but just keep in mind this is where we can see all of the logic sort of stuff. In the middle here, we have our viewport. And the viewport here basically shows us a self-contained sort of instance of our blueprint we're currently editing. You see this world around here isn't really like the previous level. We just are going to be working on our components here, positioning them just like we would in the level editor. Over here in the details panel, now you can resize panels by clicking on them on the edges and shifting them over. Our details panel is just like it is in the main level here in the level editor. When we select a component, we can modify its values. So right now I have the player self component selected. This is sort of like the parent object, which is got all of our data for the pawn. So you see here we have some data here that we can modify, some properties. We don't really need a mess of any of that. You see we also have a default scene root. Now the default scene root is basically what defines the center of the blueprint. So if we have a player, we'll probably put the player's feet just above the default scene root here, so the player's feet are the center point. Okay, we have a toolbar up here just like we do in the level editor. It's pretty similar. We have a save button, a compile button, which basically compiles all of our components and all of our event graphs. We then have some other buttons here. The play button here is basically the same as the play button in the level editor. That just opens up a brand new screen for us to play. And yep, that's pretty much it. We also have a compiler results window down here, which is useful for when we're actually setting up some logic for our blueprint, if we want to see any feedback coming from that or any errors that occur. So we got this, but you may notice that there are a few tabs up here. We have viewport, construction script, and event graph. Now, a construction script isn't really necessary for what we're using right now, so we can actually click on the X next to it right here to close that up. But you'll see that we have an event graph. If we click on that, it'll go to this window here, which is the node graph, which we can assign logic. This is the visual scripting element of Unreal. So to navigate this window here, we want to right click and we can sort of drag the window around. We can zoom in with the scroll wheel and we can select stuff by left clicking on it. Now you'll see that there are these three boxes right here: event begin play, event actor begin overlap, and event tick. Now these may seem confusing, you might not really understand what they are or what they do, but we will in the future go over each of these so you have a good understanding of how they work and how they can interact with other nodes to create some logic for your blueprint. So what we're going to do now is go to our viewport and let's create a 3D model for our player here. So I'm going to click on the add component button and I'm going to search for static mesh. Oops, static space mesh right here. We'll click on that and it's going to create a new static mesh as a child of the default scene root. So if we select a static mesh, inside the details panel here, what we want to do is go where it says static mesh. You'll see that we have no mesh right now. So let's click on where it says none, and I'm going to search for cube. There you go, shape underscore cube, select that, and as you can see here, a cube has suddenly appeared. So this here is the cube that is rendering, and let's just say we want a different material from this white one. What we can do is go down to where it says materials in the details panel, and right now it's on M basic wall. Let's click that, and we can change it to something else. As you can see here, the starter content folder has given us a bunch of new materials, so we can go through and we can select one of them right here. I'll just select this brick clay beveled. And as you can see here, we have a material assigned to the cube. Now we've got our mesh, but something else we need is a camera in order to actually see into the world and see our player. So this camera is going to be attached to the scene root here. So we'll go add component. Just search for camera, and this camera is going to follow our player around. So what we want to do, select it, make sure that the red arrow, the positive X direction, is facing in front of the camera, and we are just going to drag it back a bit here, so we'll have it at a bit of an angle up from the player. And then what we can do, press E to go to rotate, and we just want to rotate this down so it's looking at the player like so. Save that, compile, go back to the main level, and if we drag in the player blueprint here, just like we did with the cube in the modes panel, you'll see that our blueprint now appears. It is a saved object that we can bring in the level, take it out if we want to use it. Now in the next lesson, we're going to be working on actually setting up some logic for this cube. We'll be going through how to set up nodes, how the entire visual scripting system works inside of Unreal Engine. Okay, so I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at creating a game mode blueprint for our level right here. Because if you press play right now, you'll see that we don't actually look through our player's camera perspective, because if we stop this right here, we can go up to the player blueprint right here, and you see that we have this camera that we created, which is angling downwards at the player. But in the main level, if we press the play button, you'll see that we are not looking through that camera. And the reason why is because the game doesn't know that this player blueprint is what we want to control. So I can click stop here. And what we need to do is create a new blueprint, which is going to be a game mode. So over in the blueprints folder, make sure to navigate to that here. I'm going to right click and I'm going to go blueprint class. I'm going to select game mode base, which defines the rules, scoring, and other facets of the game type. And I'm just going to call this my game mode. Okay, there we go. It's got a controller icon here. Now, just like with the player node, we can open it by double clicking. And here we are. It looks pretty similar, the editor here, but really all we need to be focusing on is the right-hand side where we have these classes. And this is where we can set some of the default classes. There's quite a few here. We can set the HUD class, the spectator class. If you're creating quite a big game, you'll probably want to fill all of these in. But for us personally, we only need to fill in the default pawn class here. So we'll click on default pawn here and change that to player. There we go. Now we can go up, hit compile, which basically saves all of these options here, compiles them. We can hit the save button. We can return back to the main level. And in order to apply it to this level, in the right hand side here in the details panel, you'll see that there are two tabs. We have details and we have world settings. Details, of course, is basically the inner workings of each object that we can select in the world. But the world settings displays to us the sort of overall settings for this current level. And inside here, you'll see that there is a game mode right here. And the game mode override is set to none. Instead, what we want to do is select none. And we want to choose my game mode here. Okay, there we go. Now what we can do is press play and we should start seeing the game through the player's perspective. Okay, we got it here, but something wrong has happened, and that is we all of a sudden have two players. So if we click stop, you'll see that we have one right here, but along with this player that we manually dragged in, we also have this here, which is the player start object. And this player start here basically defines where we want our player to start. And at the start of the game, it will create us a new player. Now, we don't really want this here because we want to be able to manually place our player here just to make it a bit easier. So what I'm going to do is I'm going to delete this player start right here. And I'm going to select our player. And inside of the details panel, you'll see that underneath the pawn options right here, we have auto possess player. And this basically means when the game starts, are we going to possess the player or do nothing? So what we want to do is click on disabled and just select player 0 right here. Okay, we can save that. And if we press play again, you'll see that we now look through the camera's eyes and we are in control of the player. We of course don't have any functionality yet, so we can't really do anything here. If you do click on the screen and notice that your mouse cursor disappears, a quick way to get out of this window is just by pressing the escape key, and that will quit playing the game. Along with pressing play, you'll see how we have pause, stop, and eject. Pause will sort of pause the game as it is. So if you want to maybe capture a screenshot or go frame by frame on what's happening, you can do that here. So resume. Eject basically ejects us from our possession of the player, and it means that we can then control our own sort of level editor camera as we would if the game is stopped playing. But right now the game is in progress, so if we did have some actions going on in the game that would still be happening right now, we can click possess to possess our player again, and we can click stop to stop playing the game. Okay, so we've got our player set up, we've got our game mode set up, and we have our camera working, and our possession of the player is working now as well. So in the next lesson, we are going to begin looking at the player blueprints, and more specifically looking at how we can apply some logic to our player using Unreal Engine's visual scripting language. Welcome back everyone. In this lesson, we are going to be looking at Unreal Engine's blueprint visual scripting. So let's now go to our player blueprint, which you can open by double clicking down here in the content browser or by just going up to the tab if it's already open. So inside of the player blueprint here, we have our main area here where we work on our components, but you'll see that next to viewport, there is also an event graph. Let's click on that and it is going to take us to the visual scripter. So to navigate this area, we can hold right mouse button to sort of drag along the screen, and we can use the scroll wheel to zoom in and out. You'll see here that we have 3 nodes already created for us, and these are known as event nodes. And event nodes get triggered when something happens. So event begin play, this gets triggered once the game starts for 1 frame. So right at the start of the game, this gets triggered once. Actor begin overlap gets triggered when our collider overlaps with another object's collider. So if you're having an adventure game and you have a player that hits a spike, once our collider goes over the spike collider, we can detect that with this node here and then deal damage to the player. And event tick down here gets called every single frame. This is like an update node here. So if your game is running at 60 frames a second, this will get called 60 times a second. So to start off with, I'm going to delete the bottom 2 nodes here since we are only going to be working with event begin play. And event begin play is called at the start of the game. And what we want to do is test it out by printing something to the screen. Now to print something to the screen, we can use a print string node. And to create a new node, we can right click. And I'm just going to search up print string. There we go. We can hit enter. And there are a large number of nodes. If you right click, you'll see that there are lots of different categories with lots of different nodes to select. So we got the print string node right here. We can drag it around by clicking and dragging. And this node basically, when it's triggered, it prints something to the screen. And what I mean by triggered is the execution of the flow. And another way to think about this is electricity. Think of the event begin play node here as generating electricity, and we can plug that into other nodes so that as it goes down the line, it powers up these nodes and they do what they're supposed to do. So you'll see that on event begin play here, we have this white arrow that is pointing outwards, and this is an output execution. So we can plug this into the print strings input execution here. So these 2 nodes are now connected, and whenever event begin play gets triggered, it will straight away trigger the print string node here. And the print string node here, as you can see, has both an input execution and an output execution node. So we can carry on the progress of this flow here. So we could plug this into another node, then to another node, then to another node, and continue on the string. So when the game starts, we can do quite a few different things. Okay, so but nodes can have either an input, an output, or both. Event begin play here only has an output since this is sort of like the very start of when something would happen. And print string here can be in the middle, so it has an input and an output. And you'll see down here that it also has a value in string, and right now the value is hello. And this here is an input value. If we had a variable, we could plug this into here, and this is basically what the node is going to print to the screen. So right now it's printing hello. We can change this to whatever we want. We could say test, but let's change this back to hello. Okay, so when the first frame of the game is up, this node is going to trigger. It is going to power up the print string node, and it is going to print hello to the screen. So what we can do now is go out of here, press compile, save, and we don't have to go back to level editor every single time to play the game. We can stay in this window and just click on the play button right here. And as you can see at the top left corner of the screen, it said hello, it waited for a few seconds, and then it disappeared. I'll play that again. There we go. So our node here is working, and what we can do is when we press play, we can drag this window down and see that this node triggered this one. There was a bit of a animation here between the 2 if you caught that quick enough. Okay, so we've got that and it's working. Now how about we get some basic movement in place? So when we press the W key, for example, we move forward. Well, I'm going to select these nodes here by creating a box. Just hold left mouse down and select like you would on your computer. Hit delete. and we're going to create a new event node, which is going to be called when we press the W key. So I'm going to right click, and I'm going to search up event W, and if we scroll through this list, we should end up seeing a keyboard events tab, and in this here we should see that we can click W. Okay, so this W node right here, it has a few outputs. It has pressed and released. So this pressed here, this can create a new flow of execution for when it's pressed down, and the same for when it's released. And the key here basically outputs whatever key was pressed. Okay, so what we're going to do is once this is pressed, we are going to connect this to a node called add world offset, and make sure that it's add world offset with default scene root in the brackets, because we don't want to move the camera or the mesh, we want to move the scene root around. Okay, there we go. Now a few things popped up. First of all, the main node here, we can drag this out a bit so it's got some room, and we see that there's also this default scene root right here as well. Now this default scene root is a variable of our default scene root component, so it's basically referencing that component and plugging it into the target here. And a variable is basically a value or a reference to a component which we have. Okay, so when the W key is pressed, it's plugging into add world offset here, which is getting triggered. And this node right here takes in a target to move. So we want to move the default scene root, so it's basically moving the entire blueprint with a delta location. So this delta location here is basically the vector that is added to our existing location. So right now, if we were to press W, it would add 0 on the X, 0 on the Y, and 0 on the Z, so we wouldn't move at all really. Now in order to move, let's just change the X here, and we are going to make this a value of 10. So whenever we press W, we are going to be moving 10 centimeters forward. And as a matter of fact, let's just make this 100, so it is 1 meter. Okay, we can save that. We can now compile, and if we press play, you'll see that whenever we click on the screen to basically get into the game, press W, we are moving forward 1 meter every time we press W. There we go. Okay, so that is working. Okay, so we're able to move forward 100 meters, but how about moving left, right, and back? So using the W, A, S, and D keys, I've got a challenge that I want you to complete. Right now, we've got the forward movement set up, but I want you to try and implement movement for going left, which, if you remember, is along the y-axis, right, which is positive along the y-axis, and backwards, which is negative along the x-axis right here. So go ahead, try and implement that with what we've learned so far. W for forward, A for left, S for backwards, and D for right. I'll be right back, and we can see how we can do that. Alright, so I hope you had a go at the challenge. Now let's have a look at how we can implement this. So first of all, for moving backwards, we're going to right click, and we are going to look for the S event node here. So event S, let's try and find that in the big list of nodes here. There we go. And we want to plug this into the exact same add world offset node here. So we'll drag it off. We'll go add world offset, default scene root. You can drag this up here. You can drag this down here. And we want to set the X value here to be negative 100. So we are now going backwards. We can then right click again. We'll try and find the event for the A key, which is going to be moving us left. And now to make it a bit faster, we can actually just select these two nodes here, copy with C and paste with V, drag that down like so, plug in with pressed, set the X here to be 0, and we want to make the Y negative 100 so we can move left. We then want to implement the D key, the D event. We can then plug that into an add world offset, default scene root, and we want this here to have a X or a Y of positive 100. So we've got our 4 nodes here. They're pretty much all the same, but with a different event node and a different delta location. We can compile first, then press play, click on the screen, and if we move left, we can move right, we can move back, we can move forward. So there we go. Now the movement is pretty janky, but that's just because we're doing pretty much the most simple form of movement, but as you can see, it does work. We can move back, forward, left, and right. Hey everyone, in this lesson we are going to be working on variables inside of Blueprint visual scripting. So I'm just going to go over to this side of the screen here and we're going to be working on something right here. So to begin, we're going to create a begin play node, which gets called at the start of the game. So you can see here down in the My Blueprint tab, we have a thing called variables. And variables are basically things that we can assign a value to. So variables can be numbers, it can be text, it can be pretty much anything inside of Unreal Engine. So it can be other actors, it can be 3D models, it can be even your own custom class. This player here could even be a variable if we wanted to. So variables, it's just a way of storing things that you can change and use later on. So you can see here that we already have 3 variables under the Components tab. And this is because each of these variables is a reference to each of the components inside of our components list. So if we ever want to access the camera's field of view, for example, or even change it while we're playing the game, we can just access this camera variable right here and modify it. And the way we can do that is by just dragging in the camera variable, selecting get camera, and then if we drag out from here, we can enter in something like set field of view. So event begin play, we can plug it into the set field of view, and let's set our field of view to, let's just say 150. All right, we'll press play, and there you can see our field of view is quite large. So that's the way of accessing a variable and then modifying a property inside of that component. Now, along with this, we can also have variables which are numbers. So if you want to store stuff such as the player's move speed, the jump height, or the player's score, we can create our own custom ones just like that. So in variables, you'll see there's a plus, and what we want to do here is click on this plus variable right here, and it is going to create a new variable, and we can enter in something such as, let's just say player. Actually, we'll just enter in score like so. Now you'll see that there's a little red icon right here, and this defines the type of variable. Now, in programming and in Unreal, there are a set number of sort of default data types. And if we go up here to the details panel, once you have this variable selected, you'll see that our variable type is actually a boolean. And what a boolean is basically a true or false value. So if the game is over or if it's still running, we'll set that as a boolean. But for the player score, we don't want that as a boolean. We want this as a number. So if we click on variable type, you'll see that we have a number here of different variable types that we can choose from. And if we want to create a custom one, we can just search for it here. But we have a number of default variable types. We have Boolean, which is true or false. Byte, which is an 8-bit number. We don't really need to be worrying about this. This is useful if you're doing some multiplayer stuff. Integer, which is a integer number. Integer 64, which is a 64-bit integer number. A float, which is a floating point number. So this is basically a decimal number. Name, which is used in some cases, but it's basically text. String, which is string, so whatever sort of you type something down your keyboard, like hello. Text, this is similar to string. Vector, which is a 3D vector, so this contains an X, Y, and Z value. A rotator, which is a 3D rotation. If you want to change a rotation of object, you'll use this variable. And transform, which is got the location, rotation, and scale. So for our player score, we want this to be a whole number, so we're going to choose integer, okay? And as you can see, the color has changed here in the variables, the variable right here. And there's a bunch of other settings here, but we don't really need to be worried about this just yet. So down here, you'll also see default value, and it says, please compile the blueprint. So if we click compile, the variable will be compiled, and we can set a default value for the score. So since it's a score, we'll probably want it to be at 0, so we'll just keep it like so. And if we want to access or modify this value at all, what we can do is we can drag this score in, and we can choose set score. Select set score, and as you can see, it has an input and an output on the node. The input we can trigger with begin play, and the output we can just leave it as it is. Now, with set score here, it takes an input of whatever we want to set the score to, or we can manually enter it here. So let's just say, let's manually set the score to 5. And this output here basically just outputs the brand new score. So let's just say we input 5. This node here does some calculations. It sets the score variable to 5, and then it outputs 5 right here. Okay, we're able to set variables here But what if we want to increase it by 1? What if we don't want to set it to a number straight off the bat? What if we want to just go, okay, at the start of a game, let's add 1 to our score? Well, the way we can do that is let's just set the default input here to 0. What we can do is get our current score and add 1 to that. So what we're going to do is I'm going to drag in the score variable here, select get score. So this is going to get our score here. And what we want to do then is create another node, integer plus integer right here. And this here is basically an add node. It takes in 2 values, it adds them together, and then it outputs the sum of those 2. So we're going to take in the score here as that, and we'll have 1 here. So we'll manually enter in 1 for that one. So score plus 1, and that is going to be what we set our score to be. You may also notice that this node here, it doesn't have an input or an output for the flow. And the reason why is because this node here doesn't really save anything. It doesn't set any properties. Whereas this node here, the set score, this is assigning a new score to the score variable. So it's doing an action. This node here is just adding 2 values together and returning with the sum. And along with the addition node, we can also do some others. So we can type integer. We have integer minus, multiplied, divided, and plus. So if we have multiplied, for example, it works pretty much the exact same way. We take 2 inputs, it multiplies them together, and then it outputs a return. And along with integer, we can also do the same for if we have a float. So if we right-click and go float, you'll see that it has, if we can find it here in the list, it has the exact same ones as the addition. And there's lots of mathematic nodes. So if you want to do sine waves, linear interpolation, min, max, clamping, all those sort of things are possible with visual scripting. So yep, that is the basics of variables. In the next lesson, we are going to be continuing on with visual scripting by looking at conditions and being able to basically see if a value is higher or lower than another, and then doing something based on that. And we'll also be using our knowledge of variables in the next lesson. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at using conditions inside of Unreal Engine's Blueprint visual scripting. So in the previous lesson, we set up a score variable over here of type integer, which is a whole number. And we just looked at setting the variable, accessing it, and also modifying the variable using the addition node. Okay, so for this example, I'm just going to delete the set, addition, and the score node here. So we just have the begin play node. And what we're going to look at is conditions. And what I mean by conditions is checking to see if something is greater than, equals to, within a certain range, at a certain position, at a certain time during the game, basically anything that can divert the flow of execution for the node graph. And the main node for this is going to be the branch node. So if I right click here, type in branch, you'll see under flow control, we have branch. And this node here, if we go to it here, you'll see that it has an input and we can connect that to the begin play. So when the game starts, this branch node here is going to be triggered. But something you may also notice is that there is 2 output nodes here, 2 output flows. So which one is it going to go to? Is it going to go to true or is it going to go to false? Well, this is based on whatever this input condition is. And this condition here, seen by the red circle, is a boolean. Now, by default, it's enabled here as true. We can manually change it here. And if this condition is true, then true here, this output is going to be executed. Otherwise, false is going to be executed if condition is false. So this is a way that we can make more complex games. So it's not just running the exact same thing over and over whenever the blueprint is triggered. Instead, it can decide based on various conditions. So what sort of conditions can we do? Well, let's use a condition that we can use with our score variable right here. So I'm going to drag in the score variable, get score. And what we're going to do is we're going to check, okay, is our score equal to, let's just say 5. If the score is equal to 5, then this true is going to trigger. Otherwise, this false execution is going to trigger. Okay. So the way we can check if score is equal to 5 is by dragging off from the score output and putting this into an equal node right here, equal integer. As you can see, this integer node here, it takes in two inputs, input A, which is our score, and input B, which we can enter in manually or even plug in another node into this. So I'm going to set the second input here to be 5. And what this node is going to do is it's going to get these two inputs and it's going to go, okay, are these two inputs equal? If so, this output boolean is going to send out true, otherwise it's going to send out false. And on our branch node, we have a boolean input here, so we can plug those two into each other. Okay, so now if we were to play our game, it would check, okay, it's going to the branch node, we got to get a condition. The condition is this input equal to this input down here? If so, execute the true flow, otherwise execute the false flow. Now, what we're going to do to actually get some sort of feedback in game is by using a print node like we've done before. So I'll drag out from true here, look for a print string, and here we're just going to print out true. Otherwise for false, we'll have another print string here, and this is going to print out false. Okay, so if the execution is true, it'll print true on screen, otherwise it's going to print false on screen. Okay, so let's press play and see how that works. Alright, and as you can see here, it printed out false because the score variable here is not equal to 5. We can check by selecting the variable down here, and you can see that the default value is equal to 0. 0 is not equal to 5, so this condition is false. But what if we set the score here to be 5? Now when we run the code, it'll see, okay, score is equal to 5, so it'll be true. And if we press play, as you can see, it says true up at the corner of the screen. So there we go. That is pretty much the basics of using the branch node, and this is going to be used quite a lot in your projects because there are going to be many times where you want to check if a certain thing is true or false. Let's go over the score, for example. Let's just say you're creating a game where the player has to get 10 score in order to win. So whenever the player gets their score changed, you can put this into a branch node with an equals and check, okay, is the score equal to 10? If so, pop up the win screen. Otherwise, let them keep playing the game. Alternatively, if you have a damage system in your game, you could be checking, okay, whenever the player takes damage, is their health equal or less than 0? If so, put up the game over screen, otherwise allow them to keep playing. So conditions are things that are in every single video game, and you'll be using them quite a lot when developing your games as well. Okay, so along with the equals node, we also have some others, so we can delete that, and out from score, we could choose greater than. And there's also greater than and greater than or equals to. Greater than basically checks, okay, is A greater than B? Greater than or equals to checks, okay, is A greater than B or is A equals to B? And same with less than. So score greater than 0, we could change this to, let's say 4. Plug that into condition, is score, which is 5, greater than 4, we should have true. Okay, so greater than node, this works pretty much the exact same as equals. It takes two inputs, checks the condition, and then outputs true or false. But what if we want to check if score is within a certain range? Well, we could stack up multiple branch nodes and multiple greater than nodes or less than nodes to check, okay, is score greater than 4? Is score less than 10? But what we could do is use one of the built-in mathematics nodes, because Unreal has a large number of mathematics nodes. And what we can use is the range node. So if we type range, find in range integer, and as you can see here, it has quite a few inputs. What we want to do here is basically plug in the score and check the minimum value. So what do we want the minimum value to be? We can have that be 5, and the max can be 10. Inclusive min basically means, is this minimum included in the range? And inclusive max means, is this max included in the range? We can then plug that into our condition here. Press play, and since score is 5, it is within that range, so it is going to return true. Now, there are a large number of these mathematics nodes, like I said, so really just go around, look at them. You can right click if there's a sort of math sort of equation that you want to do. You can of course check to see if they have it. For example, if you want to work with sine waves, you can type in sine, and you see there is sine, a sine, in degrees and in radians. So there's lots of different nodes that you can use in order to really calculate whatever you want. You can do mathematical equations in here to calculate maybe the player jump height, stuff like that. In the next lesson, we are going to be looking at creating and using functions. So thanks for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we're going to be looking at functions. Now, functions are a very powerful thing in both visual scripting and in programming in general. So what a function is basically a set of blueprints, a flow, something like this, that we can put in its own sort of self-contained area and call it whenever we want. Sort of like an event node here, but a function is basically any node like this. We can call it, we can give it some inputs, and it can generate some outputs for us. Okay, so first let's create a brand new variable here of type integer, and it is going to be called times moved. This is just going to keep track of how many times we have moved, okay? And let's just say whenever we move our player, we want to add 1 to this variable right here and print it to the screen. So we want to keep track of how many times we've moved. Well, when we press W here, we're adding world offset, so we are moving. And from the execution here, we can pass on and we can add 1 to our times moved variable. So I'm going to drag the times moved variable in, go set times moved. And in order to set this variable, I'll drag the execution over to it here. So once add world offset is called, then set times moved is going to be called. But right now it's setting it to 0. We want to add 1. So to do that, I'm going to drag in times moved. Click get times moved so we get the current variable, and we are going to add 1 to that. So we'll drag it off, put this into an add integer plus integer node, add 1, there we go, plug that into that. So now whenever this set variable is called, we are going to set this to be our current times moved plus 1, okay? And finally, let's go ahead and print this out to string. You will see that this output on the set node and this input on the string node are different. So you may think, okay, we can't plug those together because they're not the same. This here is string and this here is an integer. Well, what we can do is we can actually pass it over to an integer, pass this integer over to a string by just dragging and dropping it on, and it will automatically convert the integer to a string, just like that. And this little node here is just a conversion node. It automatically creates it for us. So now, when we press play, whenever we move forward, we should print out a value of whatever times moved is. 1, 2, 3, 4, 5, and so on, okay? So that's all working great. Now I'm just going to move this over here so we have that out of the way. So we got this all here, and what we could do then is copy and paste it down here for this add word offset, this one, and this one. But after a while, it will be the exact same code pretty much duplicated 4 times, and that can take up some room. It can be a bit confusing to look at. So instead of having pretty much the exact same code 4 times, excluding the fact that the delta locations are different, what we could do is put this all into a function. All of these nodes right here, put them into a single function so it compacts the code a lot more. Because if you have a lot of repetitive nodes, it's good to put them in a function that you can easily call and send over an input which changes 1 or 2 values. Okay, so I'll show you how we can do that. First of all, go over here to where we have functions. You'll see we already have construction script here, but we're not going to be using that. So what we want to do is click plus function, and this is going to create a brand new function for us. Okay, and this function name is going to just be called move. All right, there we go, move. And you see we have a node here. Think of this as the trigger node. Whenever this function is called, or whenever this function node is triggered, this is what we want to execute. And you see it created a new tab up here for the move function. So this is separate from the event graph. This is our main graph right here. And then we have the move function right here in its own self-contained environment. So a function can just be plain like this with no inputs or outputs. It calculates everything within itself. Or it can have inputs and outputs, or just inputs, or just outputs. Well, for our function here, what we need is a delta location, because as you can see, the delta location is different for each movement. So what we need is a customizable input variable like we do with all our other nodes. So if we go back to the move function right here, we can select it in the list, and you can see in the details panel here we have inputs and outputs, and we want to create an input node right here. So click on new parameter, and this one is going to be called our delta location, just like so, and it is going to be of type not boolean but type vector, which is a x, y, and z property. Okay, and as you can see here on the node right here, we have the delta location that we can use. So now we pretty much just want to copy this set of nodes right here. So what we're going to do is have an add world offset node right here with a static mesh, same as before. But for the delta location, we're not going to manually enter in the values. Instead, we're just going to plug in this parameter that we're going to be creating and plug it into that right there. We can then drag in the times move node, go set times moved, connect that up, and this is going to be connected to an add node right here, integer plus integer, get times moved, plug that into the first one, and just like before, we're moving, then we are adding 1 to our times moved. And then we can print string, and we just want to print whatever our times moved is right now. Okay, so this here is pretty much the exact same stuff as before. If you go back to the event graph now, what we could do is just delete it all, and delete all this, and now when we drag off from pressed, instead of going add world offset, what we can do is just call the move function. There we go, we have core function move right here. Select that, and as you can see, we have the target, and this target here is basically what object, what blueprint are we going to call this function to. Since we're calling on ourselves, we can just leave it as self here, and the delta location, we can fill that in. So remember that forward is positive x, so we're going to have 100 on the x here, and this here will do the exact same as all that code we done before. So when this W is pressed, we're going to call the move function, and then the move function in here is going to be triggered, and this is going to execute all of these nodes right here. So if we press play, you should see that when we press W, it prints out our current times moved, and it moves us forward. There we go. And actually, we do have one bit of a problem, and that is in the move. We're moving the static mesh instead of our default scene root. So you can see here, it can get a bit confusing if you're moving the wrong thing. Moving the mesh moves it independently of the camera, so we can delete that node. We can drag in our default scene root here, get default scene root, plug that into the target, press play again, and there we go. You can see it printing at the top left. Now what we can do is go ahead with all the other nodes here and do the exact same. So we can just delete all of this here and just plug into it the move function node. Core function move, and to move backwards, that is -100 on the X. There we go. We can maybe move this up a bit to make it a bit neater. There we go. We got A, and then we got D. So for A, we can call the move function again, and this is going to be negative on the Y axis, so -100 on Y, and then D is going to be the move function again, and that is going to be +100 on the Y. Okay, so there we go. And as you can see here, this is basically running this 4 times, but it is hidden behind a function to make it a lot cleaner and in many ways a lot easier to manage. Later down the line, we might want to make a change to this movement thing, and with functions, all we need to do is just change the one instance of it here inside the function, rather than changing each and every time we are executing that large amount of nodes. So overall, functions just allow you to execute nodes that are repetitive, such as with this movement, how we're doing it 4 different times. So now if we press play, you'll see that each direction moves and prints out its corresponding times moved. There we go. So that there is the basics of functions. As you can see, they also have an output execution, so you can continue on doing some other nodes as well. And if you want, you can also have it output something as well. Okay, so functions, they're very powerful. You can have many different types of inputs, many different types of outputs. And yeah, overall, they're very powerful and very useful in games.